And today, we're going to actually do 1-6 today. 1-5, guys, is a pretty simple one. And especially after we do this lesson, it's going to be even easier for you. So it might be better overall teaching this fashion anyway. Okay? 1-6. So we're going to go to this problem. You guys might be like, Mr. Roberts, why am I doing 4th grade, 5th grade math? Okay? Because we're doing division today. But we're doing them with polynomials. Okay, so we're going to divide polynomials today. But how many of you guys learned the long division process? Because I know there's still people out there that don't know how to do division this way. Raise hand high if you've learned it, so I just kind of get an idea. Anybody not? Let's go that way. Anybody not learn it this way? Okay, so you gotta, for those people, you gotta really pay attention. It's a very simple concept, and you should be able to pick up on it, but I want you guys to pay attention to really what's happening, because when we go into our next, or my first problem, it's the exact same way. Does that make sense? Okay. When I do long division, the first thing I do is say what? Well, how many times can 12 go into what number? I start with 2. Can 12 go into 2? No. Can 12 go into 21? Yes. What do we do? How many times can 12 go into 21? Once. Does everybody understand how I got the 1? What do we do with that 1? Now, I know this sounds stupid. Like, I'm asking for legit sincerity so you guys understand the step when I get into what we're doing today, right? So think about every concept we're doing, okay? So 1 times 12. 12. What do we do there? Hey, but did 1 times 12 make it a negative 12? No. But we are subtracting it, are we not? Very key. I want you guys to remember that step, okay? Because it does matter. So that's 12, and notice that's 9. Oh, can 12 go into 9? So I just bring him down, don't I? You guys agree with that? How many times can 12 go into 99? 8 times. That was 96. What do we do? Subtract, and I have a 3. Oh, this actually ended up that it went in nicely, and I didn't even mean that. I just wrote up the number. How many times can 12 go into 36? Pretty self-explanatory. For those people that just saw Braden and Jenna, no, it's not. You're very, I don't know if she could draw that lovely picture. You guys know that picture up there? Yeah, she's gonna do that for me. The one, the little painting. Isn't it so nice? I tell her to draw me some pretty little trees. Bam! It's KK, it's behind the flag. Okay, anyway, this is 36, and that's 0, right? All right, okay. I'm going to do one silly one really quick one more time. How many times can 3 go into 13? We're just going to do it quick just so you guys can see it, because I actually didn't mean that to go into it nicely. It did. So let's go into something that doesn't. What is this? 3 can go into 1? No. 3 can go into 13? 4 times. 4 times 3 is 12. 1. Now I could continue on doing decimals, but I'm not going to. So this is remainder 1. You guys remember talking about remainders back in the day? But what's another way to say this? This isn't actually 4 remainder 1. What is this? Isn't this equivalent to 13 marker divided by 3 is the same thing as 4 and 1/3? Right? I take the remainder and divide by what I was dividing by. Yes, no, maybe so. Okay. Here we go. You guys ready for today? Going to transition into this. Here we go. X plus 3 going into x squared minus x, or excuse me, plus x minus 6. Notice we're dividing 2 polynomials, aren't we? Okay? The same process though. So what I do here, notice on that first one, even though it was a 12, remember sometimes how when you're doing division, you kind of like, what if it was like 24? Do we know that something by 24 can go into some numbers? It's hard, right? We actually have to like, let me explain what I mean by that and I'll erase it. If I had 69 here, If I had 69 nines like this and I have 24, do I really know how many times 24 can go into 69? In a little bit, I'm like, oh, how many times can 2 go into 6? That's kind of what I start going with, and I'm like, oh, it doesn't really kind of work. You guys remember doing those processes? That we kind of get rid of the 4 and kind of look at the front number. You guys agree with that's how you did those processes at one time doing long division? You never had to do that, Braxton. You're just like, but damn, I know it's 2. I know 3 times doesn't work into that because that's 72. Okay? No. You get what I'm saying. Sometimes you had to kind of guesstimate a little bit. At least that's what I had to do. Okay? Same kind of thing here. I'm going to ignore this 3 for right now. I ask myself, though, how many times can x go into x squared? X times what gives me x squared? I need another x, don't I? X times x gives me x squared, correct? You guys with me on that? Now, when we just did that previous problem, what did we do? Oh, what did we do? We took the thing on top and did what? Multiplied it to this item here, correct? This whole item. So I'm going to take x and multiply it by x plus 3. What is x plus 3? Times x would be x squared plus 3x. Does everybody see what I did there? Just like we did on the previous time, right? We figured out what went into it, and then what did we do? We multiplied it, correct? Now, just like previously, what did we do with that number after we multiplied it? We subtracted. Now, just because there's not a subtraction here doesn't mean that I don't have to subtract this. So what I do is I put parentheses around this, and I subtract it. Now, why do I put parentheses around it? So I understand I have to subtract this whole thing, right? Sometimes if I just put the negative here, people are like, oh, it's a negative x squared, and they forget to distribute to him. Does that make sense why I put it in parentheses? Basically, what's happening every time I do it, I have to negate the signs, don't I? Okay, so this is a negative x squared and a negative 3x, correct? Yes, yes, yes? Okay. X squared minus x squared. 0. X minus 3x. Negative 2x minus 6. Okay? Everybody with me there? How does x become negative 2x? Times is by negative 2. Negative 2 times x is negative 2x minus 6. But once again, what do I have to do? Subtract it, which does what to my sign? Just flips my signs, doesn't it? Does everybody understand flipping your signs is just basically subtracting that polynomial? Because it's distributing the negative through. So that becomes a plus, and what does this become? A plus. What does this become? 0. Let me ask you guys. If I had x minus 2 times x plus 3, would I get this? Okay. Okay, once again, when I did my normal division, brother, what did I do here? I just went 4 times 3. This wasn't negative 12, but what's the step that I do there? I subtract that number, don't I? Even though it's not a negative 12, I'm subtracting that number. Do you agree with me? Yes? Yes. Okay, same thing here. Even though when I had this, I came out with the x squared plus 3x, but I have to subtract this number, correct? So when I subtract this number, I have to distribute it in, which basically does what? Changes the sign. Does that answer your question? Does everybody get that? That's the hardest step people forget is distributing through. But does it make sense why I have to change my sign? Because I'm subtracting that polynomial from the one above. Right? That's where it's coming from. Okay? So far? Yeah? Okay, let's do another one. Now, is everything going to be nice and dandy? You're not going to have nice and dandy stuff all the time. Okay, so I'm going to just make this sucker up. So I don't know what it is, so bear with me here. All right, I just made that guy up. So if it goes in nicely, guys, it's a big miracle. I'm telling you right now. Okay? I'd be very surprised. After you guys write it down, let me know when you're ready. I'm trying to get you some examples. So far, so good. Here we go. So, question to you. How many times does it take x squared to get into x cubed? Once? So just one?
No.
An x, is it not? I need an x. So therefore, hence I put it above the things that are hex. Do I have to? Could I put it all the way up here if I wanted? Sure. Why do I do it? Just so I kind of know placeholder. All right, here we go. So I take x and I multiply it into here, correct? So I say, okay, x times x squared is x cubed, which I probably switched my color, plus 3x squared plus x. Any questions on how I got that result in the blue? Okay. Any questions? What are we going to do with that? We're going to subtract it, and so therefore, what does that mean? I need to distribute the negative through, don't I? Okay, so what does that mean? That means that this guy's a negative, a negative, a negative. Right? Does everybody understand why I'm doing that? That's usually the problem that people have is that step. Does everybody understand why I'm making all of them negative? Because definitely I'm subtracting this polynomial, which is distributing a negative one through. Right? Okay. Gone. What's here? X squared. Here. Here. Everybody with me? Okay? How does an x squared become an x squared? We times by a positive 1, correct? You with me, Jared? Nope. 4x squared minus 3x squared is x squared. Negative 5x minus x is negative 6x. Just off a little bit. Are you okay with that, Jared? Ethan? Say it again. Yes. Like your divisor? Let me get back to the next one. I'll do another example kind of like that. Is that a fair deal?
How did you get the 1 again?
Okay, 1 again. I'm asking myself, just like when I do any division, I say, how many times x squared times what number gets me to x squared? Right? X squared times 1 will get me to x squared.
Okay, you don't have to worry about the 3x.
Don't. You don't. You just ignore that crap.
Okay.
Always look at the beginning.
So how come if we're beginning, we have to send
Okay, that's the key question. Is notice last time I was asking how many times can x squared get into x cubed? So how does an x squared become an x cubed? I need an x, don't I? How does an x squared become an x squared? It already is. So now we're looking for numbers or whatever. What if this came out to be 4x squared? How does x squared become 4x squared? Times it by 4. You with me on that? So this is where I'm going to continue on here. So as I do this, here we go. 1 times all this stuff is the x squared plus 3x plus 1. Do you guys agree? What do we do? Which does what? Changes my sign. So he's negative, he's negative, he's negative, right? Any questions on where I have that? Okay. X squared minus x squared. Shouldn't it be 0? Because if you don't get a 0, you did something wrong, right? To be honest, because that was your whole goal, right? Negative 6x minus 3x. 2 minus 1 plus 1. Okay? How many times can x squared go into negative 9? It really can't, so we're done. Right? So what is this kind of like? This is like our remainder. Now, just like in our previous problem here, if I had a remainder, I basically do the number plus the remainder over what we divided by. Would you guys agree with that? Isn't 4 plus a third the same thing as 4 and a third? So here, our answer would be, what was the top again? X plus 1? So our answer would be x plus 1 plus negative 9x plus 1, what we were dividing by, which was x squared plus 3x plus 1. Am I correct? There's our answer. Now, ladies and gentlemen, that comes into play in our next test, very much so. We'll talk about that a little bit deeper. We're going to get a little bit deeper and actually talk about these and what this is doing on a graph situation. No, because once again, let me ask you this question, okay? Because you asked that. Sometimes people, when we think about these things, I want you to do it with some real numbers, okay? So what if I had 9 plus 1 over 10 plus 1? What answer should that be? In all reality, 10 11. So what you're saying is, oh, these guys are gone. Is 9 tenths and 10 11ths the same? So if you can't do it with real numbers, you can do it with all numbers. So when in doubt, if you ever have one of those ideas, try it with some numbers and see if it makes sense and you'll like it. You know what I mean? That's a lot of the times I check some of my math, which is the basic numbers, and ask myself, is this what I would do? Okay. Did you raise your hand, Paige? You good? How are we doing, guys? Not too shabby, right? Nene,
Yeah.
will you come hand me this book up here? It's just this pre-calc thing. I just want to get some better examples. I'm just making these up. So. I want to make sure everything's good. Any plans this weekend? No? What's my plan? Oh, my cousins are coming in from out of town. Yeah, sometimes there's scallywags, but I'm not gonna, talk about it. I actually like it. Wyoming. Who the hell wants to live? Right? I told my aunt one time, I said, because my cousin's actually getting married, so they're coming down because we're throwing a shower for him. No, I'm not, but my wife is and his mom, and he gets the stuff, the lady stuff, right? Nowadays, you have combined showers. So actually a baby/wedding, it's not that she's pregnant already, not saying that. But if my one cousin is getting married, and my other cousin, that's his sister, is pregnant, so we're doing a double shower, a wedding shower/baby shower. I'm not, my mom is, my wife's in charge of helping because she's part, you got what I'm saying. Okay. Yeah. All right, hold on. Ooh, Betsy. Ooh, nope. Yeah, baby, there it is. Should be more prepared, but I'm not. So I love you all. Thanks for being good people. All right, guys, here we go now. It's like a song and everything. You guys ever heard of it? No? Sure. All right, here. Oh, yeah. Here we go. This is a nice one. Okay, here we go. So I'm going to say f of x equals 8x to the 4th plus 6x squared minus 3x plus 1, and g of x is 2x squared minus x minus 2. Okay? This will be our last long division problem that we're going to be doing. Oh, yep, we're going to do f of x divided by g of x. Thank you for letting me remember that. Thank you. That is our goal. Okay? So, did you guys write it, or do I need to keep it up there for me? So our goal is, once again, what's missing, though? I go to the 4th, and then I go to squared. So we're missing the cubic term, am I not? Does everybody agree with that? So if you're ever missing a term, it's very important that you put a placeholder. Isn't 0x cubed the same thing as 0? Keep a placeholder. Okay? 0x cubed plus 6x squared minus 3x plus 1. And we're dividing by 2x squared minus x minus 2. Okay, that's our goal. You guys ready to kick trash, take names? What I do every day of my life. Okay, here we go. So I say to myself, self, how does 2x squared become 8x to the 4th? I need a 4x squared, don't I? Okay? Because once again, 4 times 2 gives me my 8, right? X squared by x squared gives me my x to the 4th. Agreed? Okay. So I have 4x squared times that is 8x to the 4th minus 4x cubed minus 8x squared. Any questions on where I found that? Okay. What do we need to do? Why do we change the signs again? Because we're subtracting the distributing of our negative, like we're subtracting, right? That didn't come out very well. Because we're subtracting this polynomial, which is basically distributing that negative to every single term. Right? Negative, positive, positive. You guys agree with me? Okay, what do we get? Gone. 4x cubed. 14x squared. Minus 3x, and I'm going to carry my 1 so I don't lose him. All right, we're on it. Junior, you ready? How does 2x squared become 4x cubed? Needs a 2x, doesn't he? Okay, so here we go. 2x times 2x squared becomes 4x cubed. 2x times a negative x is a negative 2x squared. 2x times negative 2 is a negative 4x. Once again, what do I need to do? Distribute the negative, which does what? Changes the signs, correct? Negative, positive, positive. Hi, Leslie. How's the money business? I like it. 4x cubed minus 4x cubed. 0, and it should be 0, right? 14x squared plus 2x squared. Negative x, like negative 3x plus 4x becomes x plus 1. Any questions where I'm at here? Yes, ma'am? If you don't have it come out to be 0, you did something wrong. Because what are you really trying to do? You're saying, what times this gets me to be this? What if this was even a 5? How does 2 become a 5? You times by 2.5 or 5 halves. Is it going to be pretty? Probably not, but we would get it to be that number, right? Does that answer your question? Okay, is everybody there with me? That's the part that's kind of unlike the division when we do it the other way, like by hand, because that could be off a little bit and we keep going, but it still is kind of the same thing, right? Okay, how can 2x squared become 16x squared? We need an 8, don't we? Yes? So I have 16x squared minus 8x minus 16, but I need to do, flip the signs, and I come out with 9x plus 17. You okay back there, bud? Oh, you gotta work the system. Should be staggered a little bit, huh? You can scoot your desk over a little bit and just scoot it back later. That's fine with me, huh? Okay. Okay, everybody good? Is this my answer? I need to write it. So I'm going to write this. You guys help me out because you have it on. I'm going to lose it because I'm going to scroll up. Oops. So our answer of f of x divided by g of x is 4x squared plus 2x plus 8 plus minus what? And there it is. Okay? How do we feel? Not horrible, right? But takes some thought process, doesn't it? Go ahead, Paige. The remainder. Okay? How many times can x squared go into x? There's Rick. Everybody with me? Okay. Now, this is the hard one. There's another one that we can do, which we're going to go back to our very first example. What was the very first one that I gave you guys? It was what? X squared plus x minus 6 divided by x plus 3. Okay? Now in this one, it's hard to explain how it happens. I need you guys just to trust me a little bit. Okay? Bear with me. This way is going to be your baby. This is the one you're going to love. Not the redheaded stepchild. If you're a redheaded stepchild, I'm not really trying to mock you into that. Okay? Okay. So, because all my siblings are redheaded stepchild, I'm a half redhead. Because I'm a chingy. This is pure blonde, people. I'm telling you right now. Okay. This is called synthetic division. The last one was long division, just like we've done long division. This is called synthetic. Okay. Synthetic division can only be done when you have a binomial. Okay, so if I was dividing by that 2x squared minus x minus 2, could I do so? No, because that was a trinomial. Does that make sense to everyone? I would not be able to do that. Okay, is everybody with me? What was the answer to this when we did this the first time? Wasn't it x minus 2? Yeah, but it's really going to come out the same way. Once again, please trust me a little bit. If you guys have questions, please ask, okay? What I'm going to do is, what's the coefficient on x squared? 1. What's the coefficient on x? What's the coefficient on our constant? -6, right? Is everybody with me there? Notice, ladies and gentlemen, I just wrote down the coefficients of every term. Remember that one that we did that had a 0x cubed? If it didn't have an x cubed, what would I have to put in there? Or something of that case. I still have to put a placeholder in here, just the same way. Does that make sense to everybody? Okay. So, what I would like you to do, and I'm going to explain this in just a minute. Draw a bar down. Go over and down. It might not look exactly the same way as your book, and some other teachers might show it like slightly different, but this is how I show it. Okay? What was the binomial that we're dividing by? X plus 3. What's the value that makes him 0? -3. I put that number here. The number that makes the binomial 0 is what we're going to divide by. Now, if you'll notice, guys, what did that just happen? Basically, we just switched our sign, didn't we? So do I ever have to subtract? I'm going to add every time. Okay? Here's the process now. Just watch. Hence, I put this line here. The reason being is I always pull down that number. Whatever that number is, it's always going to be right here. And the reason being is it is a binomial. Okay? And how many times can x go into 2x squared? 2x times, right? It's always going to be that coefficient. Does that make sense to everybody? Okay, -3 times 1. Because I've already switched my sign, what do I get to do here? I don't subtract, I add, so that becomes what? What's -3 times -2? +6. Right? -6 plus 6 is? Here we go, ladies and gentlemen. This was x squared. So if I divide by a binomial, what do these answers represent? An x. So this is x minus. There's your answer. Okay. So, did we do another one that was divided by a polynomial? Just like by a binomial, or did we only do the one? Okay. We'll make it up then. Yes, sir. By a binomial, yes, sir. So, it can be any term. It can be, go ahead. It can be any polynomial we want, right? Meaning, it can be raised to x to the 5th, x to the 6th, whatever. But when I'm dividing, what I'm dividing by, since that has to be a binomial. Does that answer your question? Yes. This 6 right here, I take this number times it by this number. So -3 times -3. Yes, sir. Yes, sir. You always bring it down, hence that little number right there. Does that make sense? All right, just trying to get you guys, sorry. All right, here we go. Okay, so I have x cubed plus 4x squared minus 6x plus 1. What are we going to do? First off, we write the coefficients. Does that make sense? What are our coefficients? 1, 4, -6, 1. Okay, has everybody got that? X cubed, x squared, x constant.
So you don't like the coefficient?
No, because that's what we're going to divide by. Bring down, over. Okay? All right. What's the value that makes this binomial 0? 1. Bring down the first coefficient. 1 times 1? 5. 5. Nope. This one I don't change the sign because what's the value that makes this 0? What do we see here though? Because we've already kind of changed the sign already. Does that make sense to you? Because we've already kind of changed the sign from being this to a positive 1. It's already switched my signs for me. So all I have to do is add. Does that answer your question? 1 times -1. What do we get? Do they always come out to be 0? Okay, here we go. This was x cubed. So what does this mean this is? That says x squared plus 5x minus 1. You guys want to do long division to see if it works? Same? Okay, so once again, how did I get this, right?
Yeah.
The numbers left over, this was x cubed. How many times can x go into x cubed? X squared. So every time you do it by binomial, you're going down 1 degree. Because how many times can x go into x to the 5th? You're going down to x to the fourth. Does that make sense to you? Everybody with me on that? Why it's going down by 1 degree? Because you're saying how many times can x go into some other polynomial that's a higher degree, right? So it's taking it down by 1 every time. With me on that? Okay. Notice, what if this number right here changed? What if this was, let's just pretend that was an 8. So notice this is still x squared plus 5x minus 1. What does this 8 represent? The leftover, the remainder. Does that make sense? It doesn't come out nice, that's the remainder. I'll show you in just a minute. We're going to do another one. But I just kind of wanted to make sure, does it always come out to be 0? No. Okay, sometimes it comes out to be a number because not everything goes into it nicely, right? I'll write one that isn't so nice. Here we go. Let's say if I did 2x squared minus 4x plus 4x cubed, oh my hell, 5x plus 1 divided by x plus 9. I made that sucker up, and hopefully it's the nastiest thing you've seen in your life. Like going into a dumpster and eating food. You gotta do it, that's what we're doing. Sometimes desperate times is desperate measures. You guys ready to rock and roll?
Yeah.
Here we go. So what is our coefficients? 2, -4, 5, 1. What are we dividing by? -9. Does everybody understand where I got that? All the coefficients, the value that makes this 0. Okay? Here we go. 2. You just bring him down. -9 times 2. Just give you a hint, that's 198. $18.27. -$18.27. I told you I made it up nasty. What's left over? So how do I write this? That's what your question was, right, Trevor? Okay, so here we go. This was an x cubed. What's this? X squared. So I have 2x squared minus 22x plus 203 plus -1826 divided by who? Who are we dividing by? X plus. Okay, I'm going to show you. Yes, sir. Negative. Still go here. Always come back to this guy. Well, how it's just the same thing. Notice, brother. Negative times a negative is a positive. Then I come down. That becomes a positive number. Negative times a positive is a negative. That's the only reason I'm taking a -9 times by a positive number. Does that answer your question? Can I show you that really quick? Can I show you? What do you have really quick?
You did a long division?
I would, but I don't have as much time. I need to get some to it. You can check it and try it. It'll come out to be the same though. Okay, I want to do try. What if? Let's call this guy f of x up here again. Okay. So I want you guys to tell me, how would we find f of -9? Tell me what I would do. Every time I saw an x, I would plug it in with a -9. You guys agree? Okay, so what was our equation again that I wrote? It was 2x cubed, right? So it's 2 -9 cubed. What was the next term? Minus 4x squared, which is -9 squared. Plus 5x, so 5 times -9, and then our constant was 1. Okay. Hurry and tell me what this answer is. Plug it in your machine. Hurry and tell me what it is. Didn't it come out to be negative 1826?
Yeah.
Okay. Called the remainder theorem. Is what I'm going to show you right now. Does everybody get it? If you'll notice, when I plug in whatever I'm dividing by, it'll tell me my result. The remainder will tell me my result of that is if I plugged it into the function. So f of negative 9 is negative 1826. So I'm going to write just a whole new equation, okay? Let's just do something we can see easily in our head. Do we all understand that if I plug a 1 in here, that becomes 1 plus 4 plus 1? So f of 1 gives me what? 6. You guys agree with me on that? Yes or no? This is what the remainder theorem is. What it is it's just doing long division or synthetic. 1, 4, 1. I wanted to find 1. Ready? Begin. 1 times 1. That's the remainder theorem. So, on your test, I'm going to tell you right now, I'm going to say find f of 5. Are you going to be doing it just by plugging it in? Or what are you going to be doing? If I ask you for the remainder theorem, find f of 5 using the remainder theorem. You do this. So let's do what f of 5 is for this thing here. All right, what's f of 5? So we use our coefficients. 1, 4, 1. Number I'm going to be using is 5. Pull down the 1. 5, 9, 45. Notice I can check it if you guys want me to. 5 squared is 25. 4 times 5 is 20. 25 plus 45. Oh my heck. 25 plus 20 is 45. 45 plus 1 is 46. Your remainder will always be the value of that function when I plug it in. That's the remainder theorem. And the reason being is what we're doing is trying to figure out when this guy is 0. So this is the thing that makes it 0, and if it's 0 or goes into it nicely, you'll have a 0 remainder. Does that make sense? And if it doesn't, it'll be what's left over. Okay, here we go. Okay, I'm going to assign odds again, but this is something, guys, that if you don't practice, you're going to struggle. Okay, so please put in the time and effort. If you need to do more than odds to make sure you're getting it, please do so. Okay? All right, odds on 1-6. Odd.